So with that, I'd like to turn it over to our program director, who is Clinton Hilliard, and we've got a real treat tonight. It's Dr. Howard Eisner, and I'll let Clint introduce him, but most of you know Dr. Eisner. He's always a treat to listen to. He's really iconic within the community, and it's with he's held in very high esteem by engineers nationally and worldwide. So tonight should be very, very interesting to hear from Dr. Eisner. And Clinton, go ahead.
Okay. Thank you, Mark. So my name's, like Mark said, I'm Clinton Hilliard. I'm the programs director for the Chesapeake chapter here. And tonight, along with my co-host, Paul Martin, we'll be administering this lecture here. I want to welcome everybody for attending. A couple of preliminaries here. First, we're going to be raffling off a door prize, and it's going to be Dr. Eisner's most recent writing here on system architecture. That will be the door prize. I'll announce that at the end of the lecture. And then secondly, put your questions, if questions come to mind during the presentation, type them into the chat window. Let Dr. Eisner judge whether he wants to answer them now, or more than likely we'll hold them to the end, and then we'll review them and answer them. All right, tonight we are honored to have as a special guest a man whose career spans 30 years of working in industry and another 24 years in academia. His experience in industry has covered the full spectrum, from working as an engineer to management and up through being executive and president of 2 high-tech companies. His career further extends into academia, having been professor of engineering, management, and distinguished research professor at the George Washington University. He's taught courses there in systems engineering, technical enterprises, project management, modulation and noise, and information theory. Since 2013, he served as professor emeritus at George Washington University. He's written many books related to engineering, systems, and management. Like I said, tonight's door prize is going to be one of those books. So with all that, I'd like to now turn the presentation over to our speaker, a literal legend in the profession of systems engineering, Dr. Eisner.
Okay, well, this is the sort of introductory slide. Originally, we were scheduled for a slightly different idea back in May, but here we are in October, and we're going to be talking about a subject near and dear to my heart, namely systems architecting. I'll be referring from time to time in the next hour to various items in this book called Systems Architecting that we auctioned off just a few minutes ago. So let's go to the first substantive slide. That's it. Some of the basic ground rules I'm going to be talking to is a definition, if you will, of an architecture. Not very good definition, but you can see it. System structure is a systems architecture and a framework. The origins of architecting systems really go back quite a long way, but the more recent one is around 1995, when a CQ-DI committee got together to develop a framework for architecting CQ-DI systems around 1995, so that's 25 years ago. Various people have published articles and regarding what is an architecture and what's that all about. So a convenient point of departure, if you will, is 1995. And what came out of that was the so-called DODEF, DOD architectural framework. I'm going to be talking about some of the details of that shortly, but the basic idea that I'm going to be presenting is not DODAF, but my own procedure, if you will, for how to architect a system. The essence of the presentation is systems orientation and basically the simplicity of the four-step process that it says it's a new process, but actually you'll discover that I've been teaching that and using that for quite a few years, probably of the order of 20. It's a repeatable process in the sense that you have 4 steps and you follow the steps and you get to where you want to be. What we're headed for is an idea that winds up looking for what I call the knee of the curve concept in terms of cost effectiveness of systems. If you go back a ways and you look at some of the DoD admonitions, you find that in many ways they go back to those key words, cost effectiveness. They are looking for us folks to be building systems for them that are basically cost effective, provably cost effective. Now, you don't find that in the DoDAF approach. So we're moving to a different sort of idea. That there's a curve that pertains to systems, meaning large numbers of systems. And that curve basically starts out, if you look at cost effectiveness, it starts out at low cost and low effectiveness, and it climbs from there to more or less in a linear way to a knee of the curve. So it sort of bends over to the right where the costs begin to increase at a rapid rate as the effectiveness sort of saturates out. So if you can envision that, you have the notion of ensembles of systems, or systems of systems, if you will, obey that kind of curve. And what we're looking for in the procedure that I'm going to be talking about is the knee of the curve, at least theoretically, the knee of the cost effectiveness curve. Now, where we want to be on that curve is not 100% determined, but for some applications, you want to be in a place where your costs are low and your effectiveness is relatively low, but climbing in a linear way. And then for other types of systems, for example, military systems, you want to be at the right-hand side of that, where the costs tend to be high and the effectiveness is sort of saturating out. It costs you a lot, if you will, to buy that additional amount of effectiveness. So I'm using these words, and you'll find that, again, compared to DoDAF kinds of words, they're not really the same. The notion of providing a cost-effective system to our customers is where I'm headed with this kind of an idea. And then the last bullet on this slide is we're not talking about architecting the enterprise. We are talking about architecting the system, not the enterprise, but the system. There's a lot of activity going on about enterprise architectures, but that's not what this is all about. Okay, let's go on to the next slide.
All right, hold on.
Okay, one very important question, of course, is what exactly is an architecture? I had provided a definition of this. It goes back to a book I wrote back in 2008. I think Ron Luman might have been around, one of my students around that time. But here's my definition, and it's pretty important to read it carefully. An organized selection and description of design choices for each of the system functions and subfunctions. Okay, a selection of design choices for all of the system functions and subfunctions. So what we're talking about is you have to basically hang on to the functions and subfunctions, and that step, of course, is functional decomposition. Again, this differs quite a bit from the DoD approach. And my step number one is, what are the functions and subfunctions that the system is supposed to provide? We have to be very careful about that. We have to be kind of precise about that. And we have to understand that as we design different choices for these functions and subfunctions, we are synthesizing an architecture for the system. Okay, so if you think about that for a while, you can also make note of the fact that you may have more than one design choice for, let's say, one of the subfunctions. You may have 2 or 3 design choices. And as you begin to look at the combinations of design choices for each of the functions and subfunctions, you are literally developing a set of architectures. So that's where I'm headed in this discussion. We're not going to have one architecture, we're going to have several architectures. Now, why are we doing that? Well, we're in search of the most cost-effective architecture. And in order to do that, we've got to look at several of them. From that, eventually, we will select a preferred architecture. And that's going to be a choice that we think is the most cost-effective approach. Again, this goes back to 2008 when I documented this approach. And to make it more real, I hope that definition makes some sense to you, but to make it more real, I'm going to jump into an example. So let's move on to the next slide. Okay, these are the steps. There were just 4 of them. Each one is pretty clear, I think, and I'm going to walk my way through it. These are in the current book, Systems Architecting, that came out basically this year. So let's look at step number 1, functional decomposition of the system in question. Let's let me go to the next slide, and I'll go through that step. Here's an example of what we mean by functional decomposition, and it is step number 1. We're not at all headed for the 3 views of systems or architectures that DODEF gets to. We're not headed at all in that direction. We're headed specifically at what are the functions that the system is supposed to perform. Now, this example was done by one of my students. He may be in the audience, but he is at Johns Hopkins Applied Physics Lab. And over the years, I've used this example, which is at one level pretty straightforward, and another level pretty simple for purposes of illustrating how this works. So if you look at this, you find that the system, it's a severe climate anemometry system, and it basically has just 4 major functions. You can see them: atmospheric sensing, mechanical service, environmental service, power service, and indoor-outdoor transmission and data handling. The architect in this case, Dr. Anderson, said this is it. These are, in fact, all of the functions. There are no hidden functions. And this is how he wants to define it. Now, beyond the 6 major functions are a set of sub-functions, and you can see them on the slide. For atmospheric sensing, we have 3 sub-functions: wind speed sensing, wind direction sensing, and pressure sensing. Mechanical service, just 2 sub-functions: instrument housing, orientation, and position. Under the 3rd function, environmental service, we have just 1 sub-function, ice control. And you can see the other sub-functions. Now, as a practical matter, why do I have not go to sub-functions? Well, for purposes of architecting, basically my experience is this is it, the functions and the sub-functions. And when you continue with the procedure, you wind up with an architecture, or actually several architectures. So let's go beyond that and take the next step. Now, what did we say we were going to do? We said we were going to identify design approaches for each of the functions and sub-functions. So if you look very carefully, this is the synthesis step. The synthesis step being specifically the step of architecting the system in question. So stare at that for a little bit, and I'll work my way through it step by step. So we have atmospheric sensing is the function, and the 3 sub-functions are wind speed sensing, wind direction sensing, and pressure sensing. Now, what we are in search of is a architecture, a preferred architecture, and we're trying to get to architectures, in this case 3 of them, that represent points, so to speak, on that curve I was talking about for an ensemble of architectures. So if we look at wind speed sensing, we ask ourselves, what's a low-cost approach to wind speed sensing? And we decide that a commercial off-the-shelf pitot tube, pitot approach, is a good way to do, a good low-cost way to implement, instantiate, if you will, that measurement. Low-cost approach of wind speed sensing is a COTS pitot. If we move up in capability or effectiveness, we can add a transducer to that, and we are in search of the knee of the curve of that ensemble curve. And for high effectiveness, we add a radio transducer. So just stare at that for a little while, and you can see what's happening here. We're actually instantiating 3 different architectures. And we do that by increasing the effectiveness represented here for subfunction number 1, wind speed sensing. Now, if we move beyond that, we go to the second subfunction, and that's wind direction sensing. And our implementation or instantiation of that is we use the shaft drive, the position of the shaft drive. And for all 3 of our instantiations, or all 3 of our architectures, we're using just one approach, the shaft drive. And then we move down to pressure sensing. We're using the same instantiation as we did for the wind speed sensing. So look at this very carefully, because this is the guts of the overall approach. We're at the subsystem level. We are actually looking at not 1 architecture, but 3 architectures. We're looking at an architecture that we believe will represent a low-cost approach. We're looking at a second architecture that is, we hope, will represent where the knee of the curve of that ensemble of architectures is. And then we have the highest effectiveness, which would be the column all the way on the right. So this is the essence of the entire procedure. And you can see how pretty straightforward it is. Now, if you decide that there's another design approach, well, you might add another high effectiveness design approach to the right of the one that says high effectiveness, and you might call that high effectiveness number 2, and do the same procedure. And now you have 4 architectures. Now, what you have here is developing more than one architecture, and sometimes the words that are used for that are called combinatorics. And it's up to the architect to decide on 3 or 4. But my recommendation would be go to 3 or 4 architectures. And then we're looking for an architecture that is the most cost effective. Well, the implication of that is that we have to be able to calculate the cost and the effectiveness of each of these 3 architectures. If we move down to mechanical service, we see exactly the same thing happening. We have a low-cost approach to the instrument housing, okay, the machined aluminum approach. To get to the knee of the curve, we're looking for adding molded compression. And for the high effectiveness, we are going to a lesser weight. For the orientation, in terms of mechanical service, we decide what our design approaches are for the 3 cases represented here. Again, the 3 cases for orientation, the low-cost approach is vaned bearing. The knee of the curve is less the tail boom, and the high effectiveness is precision bearings. Now we move on to the 3rd function, and in this case, environmental service, which has only 1 sub-function, but we have a design approach for each of those 3 architectures. Moving down to the 4th function. This is the critical slide of my procedure. I call it the synthesis slide. This has the functions of indoor-outdoor transmission and data handling. And the outdoor transmission has power transmission. And then we're looking at a low-cost approach to power transmission. The stranded wire harness is the low-cost approach, but also is the knee of the curve wire harness. And going to the right and increasing effectiveness are custom slip rings. So I hope you get the hang of this, because this is the centerpiece of this entire procedure. Furthermore, this is my definition of an architecture. Okay, this is the architecture. So when you get to the point of saying, well, what exactly is an architecture? The answer is, not only is this an architecture, it's 3 architectures on 1 piece of paper. Okay, what could be simpler? Okay, so I hope you're with me on it. You go down to the next function, data handling, and continue with that. So let's move on to the next slide, and try to show how this might work if you were architecting a house. First, you do the functional decomposition, as I've mentioned earlier. And this is a way to do it. What are the functions in the house that you're trying to build? There's an eating function, a food preparation function, a bath function, a recreation function, et cetera, et cetera. This is a critical part of the entire procedure. You must start with the functions. Why are you doing that? Well, you're trying to be clear about what is it that the system is supposed to do. What are the functions that the system is supposed to carry out? And in most of the cases that we look at as systems engineers, this is pretty clear. This is the first thing that tends to be documented when a customer or a stakeholder is saying, well, here's what I want. I want these functions to be carried out by my system. Okay, and then you see what the second step was, the synthesis step, which you take each function and you break it into subfunctions. Let's go to the next step to get an example of that. Let's take the first function, that's called eating. And we have three approaches to the function known as eating. The low-cost approach is the standard dining room. Our increased capability is the knee of the curve solution, which is 1.5 times the standard. And the high effectiveness is twice the standard size of the dining room, and with a high ceiling. Now, where are these coming from? They're coming from the architect. The architect is deciding what is it that represents the function known as eating. And in point of fact, it's not only doing a single architecture, but it's doing 3 architectures. We go to the second function, that's food preparation. Essentially, we're talking here about the kitchen. And we are identifying 3 approaches to a kitchen, to instantiating a kitchen. And you can see what they are: standard plus high-end extras, and extra equipment and counters for the high effectiveness approach. We do this for each and every function and subfunction. And we're architecting not one architecture, but 3 architectures. And we're trying to get to a low-cost approach, a knee of the curve approach, and a high effectiveness approach. You can see where we're headed here. We're headed for the cost effectiveness evaluation of several architectures. Okay, we go through the architectures one at a time. And this is where the architect, or architects, if there are several of them, get paid for doing what they are supposed to know how to do, which is to come up with design approaches to instantiate each of the subfunctions for the system in question. Now, you don't see any signs here of a thing known as a operational view or systems view. You don't see any sign of it. In other words, this is completely different from a DODAF approach. And I'll go through some of the reasons why I came up with this in distinction to the DODAF approach. Okay, let's move on to the next slide. This is page 2. And we have new functions: electrical function, car facility functions, living space function, etc. And the architect is coming up with the 3 different approaches. Okay, if there's reason to believe that there should be a 4th approach, then that should be on this piece of paper. And we would be architecting simultaneously 4 architectures on one piece of paper. What could be, what could be easier? Okay, let's move on to finish up this step, otherwise known as synthesis. This is the synthesis step. And this is the critical step of coming up with design approaches for each of the subfunctions of the system in question. Well, what you might expect at that point is that, well, we're trying to get a handle on which is our best system, which is our most cost-effective system. And in order to do that, we're going to use a classical cost-effectiveness analysis. We define a set of evaluation criteria. And in this case, I've identified for illustration purposes 5 evaluation criteria. So what is this all about? This is the analysis step. We do a synthesis step. We do follow that with an analysis step. The analysis step basically says what are the most cost-effective answers to this particular system architecting problem. The simplest way of looking at that basically goes all the way back to 1965, when the Department of Defense came up with a thing known as the WESIAC approach, where they basically had to come to terms with, well, how do we measure effectiveness and how do we measure cost? Literally goes all the way back to that idea. So this is a analysis step along those lines, where we're trying to evaluate and will in fact evaluate the 3 architectures with these 5 criteria. And this is a simple case of rating and weighting. And these are measures, if you will, of effectiveness of the 3 architectures in question. The names of the architectures are System A, System B, System B. We really mean Architecture A, Architecture B, and Architecture C. For the first System A, remember we were looking at the low cost approach and the low effectiveness approach. And we do the weighting and rating against the criteria, and we come up with the sum of 7.2. That is the measure of effectiveness. Again, if you all go back to the WESIAC approach and the origins of cost effectiveness analysis, which is pretty well documented today. And the sum is the MOE, measure of effectiveness. That is for Architecture A, the low cost one. For Architecture B, the knee of the curve is measure of effectiveness 8.1. And for the high effectiveness solution, we have a measure of effectiveness of 9.0. So we're doing a classical cost effectiveness analysis and move the entire problem into that domain. So what I'm basically saying is that I found some years ago that this worked, and spent a fair amount of time in my various classes over the last 15, 20 years using this approach and having my students had that as a class assignment, and it worked out pretty well. Ron Lumen is in the audience, and if he wants to talk about that during our Q&A, I'd be happy to hear from him if he recalls what happened in his class some years ago. All right, let's move on to the next slide. So what we have here in this step 3, known as analysis, we're analyzing the 3 alternatives. And we have alternative A, we got a number of measure of effectiveness of 7.2. And the cost, to put some numbers to it, 800K. We're now architecting a house, and the cost of the house is 800K. For the knee of the curve solution, the measure of effectiveness is 8.1, and the cost of that alternative was 1.2 mil. And for the high effectiveness solution is measured with 9.0, and the cost of 4 mil. So here we have the cost and the effectiveness of the illustrative case, which is the house. And the effectiveness is being measured here on a scale of 1 to 10. We're using weighting and rating schema. And which alternative, I guess, is the next question, which is having looked at the different alternatives, which alternative would you choose? Well, that's a more complicated question, but I guess I'd put it to the architect and the architecting team and say, well, which alternative would you choose? Classically, the cost effectiveness analysis suggests that for the low cost approach, you would choose that approach if you don't have the money to put up for the other two approaches. And you get a more or less linear improvement in effectiveness for linear increases in cost. So I guess the answer to that question would be, if you don't have the money, choose the low cost approach. Now, can you identify with that kind of approach or idea in the systems that you deal with for customers in the real world? Well, I think you could basically say, if I'm building a plain vanilla system for a customer, let's say a personnel tracking system, relatively easy to build, relatively easy without the complicated real-time applications. And so I would probably choose the low-cost approach for that case. When would I choose the second approach? Well, I would do that when I have more money to spend and I'm in search of an approach that is what we might call the most cost-effective, the knee of the curve approach. And then finally, you would choose the high-end approach in the case, for example, of military systems, where you are determined to have the highest effectiveness. We don't want to go to war with a system less than the best we know how to build. But what we have to do is we have to pay for it. So we're on the right-hand side of that curve. The effectiveness is saturating out. We're getting less and less effectiveness for more and more cost. So the whole principle behind this idea of architecting is we're searching the cost effectiveness space for one or two or three approaches: low cost approach, knee of the curve approach, and high effectiveness approach. We're putting all of these answers on one sheet of paper. So I am basically trying to make the argument that this is very, very different from DODAF, and we'll spend a little bit of time talking about that. Meanwhile, think about what I said on the which alternative would you choose, and think about what the process is that we're going through. We're trying to put the problem, the entire architecting problem, in the context of cost and effectiveness analysis. It's very, very different if you have followed the DODAF approach, and probably all of you have. And we're in a completely different place. So I guess my argument has to sort of convince you that this is a better place to be than the DODAF approach. So let's go on to the next slide and see what's there. Okay. What we can also do is, if we want to get more fidelity in terms of evaluation, we can have more detailed evaluation criteria. So, for example, I put 5 criteria before. We can break the performance criterion into 3 or 4 sub-criteria. We can do the same with human factors, maintainability, risk, and sustainability. In other words, if we want to represent a greater number of evaluation criteria for the analysis step, we can do it in this particular way. Now, why would we do this? Well, we would do it if we believe that there are stakeholders that are interested in these criteria. If we have a stakeholder that has basically come out and said, well, I'm interested in sustainability of the system, or I'm particularly interested in maintainability, we would expand these criteria into sub-criteria and carry out the evaluation on that basis to get greater fidelity for and possibly other stakeholders that are interested in it. Okay, let's see what's on the next slide. Okay, we also can see areas for trade-offs just looking at the synthesis chart. We had, if we went back to the synthesis chart, we'd remember we had a power transmission example. If we don't like what we see on that, we can add other design criteria and other design approaches. There were 1, 2, 3, 4, 5 cases where we could add trade-offs right on that particular example in terms of the synthesis of alternative systems. So we have a single piece of paper where we're looking at trade-offs amongst different design approaches. We're staring at one piece of paper, the synthesis chart. Recall that the synthesis chart has subfunctions and it has alternative architectures. Let's move on to the next slide. And that same slide on synthesis is a good slide for looking at areas of interoperability. So we start out at the top for the first function and the first subfunction of that, and we move down the slide to see if that design approach is interoperable or not interoperable with the one above it. So in this case, looking for interoperability, again, is looking at the same slide, synthesis slide, but instead of going from left to right on that slide, we go from top to bottom. And we confirm or not confirm the interoperability of the alternative design approaches. So we have, again, a hopefully very simple approach. Now, who am I following when I choose to claim that this is a simple approach at architecting? I think you all know the person's name. His name is Eberhard Rechten. And if you recall his book, which is the seminal book on architecting, he basically said, look, the way to approach this is the simplest approach. Keep it simple, if you will. So the approach I'm choosing in doing the EAM is the Eberhard Rechten approach, the cost effectiveness approach, and not the DODEF approach. Okay, I think that might be the last slide. Well, no, it's not. Expanding upon the evaluation criteria in different domains. If we're taking a look at transportation domain or the communications domain, here are other evaluation criteria that we could be using. And we're evaluating the alternatives against these typical sets of criteria. I'm sure all of you have recognized this for these types of systems. Okay, let's move on to the next one. The final commentary is that for the example of architecting the houses, we had a cost, we had effectiveness of 7.2, 8.1, and 9.0. We had the cost of 800K, 1.2 mil, and 4 mil. Are we at the knee of the curve? We don't know whether we are or not, but we are able to come up with our preferred levels of functional decomposition, namely 3. We can obtain a deeper level of evaluation with more criteria. We can visually see trade-off areas on one piece of paper, and we can visually see interoperability areas also on one piece of paper. Finally, I've used this approach in my classes for many, many years. I actually have contributed to the one story I'm going to tell. I had a student some years ago who was so intrigued by this particular approach to architecting. He said, I'm going to start a company based on this approach of architecting. And guess what? He started a company, the company is flourishing, and he tells me that it's all because of his commitment to architecting systems in this way. One thing that he did discover, and I think I've discovered over and over again, that when you put the synthesis step in front of a customer, they fall in love with it. So that's my final commentary, but I want to make a few comments about the DODEF approach. You can tell I'm not a fan of the DODEF approach. In the DODEF point of departure, of course, are these 3 views. Beyond the 3 views, you want to ask yourself, where does the DODEF go from there? Well, the beginning points, of course, are the 3 views: the operational architecture view, the systems architecture view, and the technical architecture view. My approach is completely different. And if you recall, the DODEF approach, beyond the original 3 views, has a set of essential products and a set of supporting views. The essential products are, recall, AV1, AV2, OV1, OV2, OV3, SV1, and TV1. So my question to you is, where do those come from? And where do the supporting views come from? Well, you can, I think where they came from was the good sense of some smart engineers, but basically, to me, it's moving in a direction where you're not defining architectures. You're defining views of architectures, which don't actually, not the same as architectures. The propositions that are discussed in the book basically argue that the accurate and relevant views of an architecture cannot be set forth until the architecture has been well defined. And the DODEF approach basically doesn't define architectures from my point of view. So you can accept that or not accept that as a way to proceed. Furthermore, an accurate architecture cannot be reliably inferred from the 3 views that are the starting point from the DODEF approach. Now, one last point I'm going to make about this is the following. Let's suppose the problem that was put on your desk is your boss is saying to you, we want to architect the human body. I want you to sit down and develop an architecture for the human body. I want you to start out with the three views. Start out with the operational view of the human body. Start out with the systems architecture view of the human body. And then add to that the technical architecture view of the human body. Think about that for a little bit. And think about whether that leads you to an architecture. My claim is that it doesn't. Now, what does lead you to an architecture? Well, I could take a picture of the human body. I could take three views. I can take a picture from side to top, and I could stare at those for a while, and I could say, here are three views. And does that lead me to an architecture of the human body? My claim is that it does not. What does lead you to an architecture of the human body? Well, think about it for a minute, and you find that where you're headed for in that answer is functional decomposition. In other words, you're headed for the first step being the functional decomposition of the system in question. Now, what is a functional decomposition of the human body? Well, let me name some of the functions. The immune system, the immune function, circulatory function, the nervous system function, respiratory function, reproductive function, digestive function. So what I'm arguing for here is that the more natural approach to architecting systems is to start out with the functions and the functional decomposition, move from there to the articulation of design approaches for each of the functions and subfunctions, then evaluate three architectures as a minimum, and go into a cost effectiveness evaluation as your overall approach. Okay, that's took us to approximately 1 hour, and we can move into the half hour of Q&A, and I'd be happy to entertain any questions or comments or that you would like to make.
Thank you, Dr. Eisner. Let's go ahead and if you have a question, if you don't mind unmuting, we think maybe Dr. Howard might not be able to get to the chat, but if you don't mind saying it out loud and he can answer you.
Okay.
If anybody has questions. I do have a question. I was looking at your cost one. Would there be a situation where you would put cost in as part of your evaluation? So rank your cost and throw that in there and make that part of your analysis? Or do you try to separate?
Typically cost effectiveness evaluations keep it orthogonal.
They do, okay.
And they don't blend the cost in with the effectiveness. So typically the answer to that would be typically no. You're in a mode where you're looking at a chart. The chart is the y-axis is effectiveness. The x-axis is cost. And you're looking at points on that curve that represent architectures.
Oh, that makes sense. So you're trying to get to where maybe the lines cross, or you're trying to get the best bang for your buck by looking at costs separately.
Yeah, you
Okay.
tend to think of cost as an orthogonal
Okay.
approach in just about all of the cost effectiveness evaluations that I've run into over the years.
Okay. Well, I've been always taught for analysis of alternatives. I usually throw the cost in, so that's an interesting way to do it. Thank you.
Okay.
Yeah. I'm gonna have to rethink it. All right.
Well,
Anybody
again,
else?
think of that chart, the cost effectiveness chart, and the chart is again y-axis is effectiveness, x-axis is cost, and the points in that domain are those three domains: the low cost approach,
Yeah.
the knee of the curve,
Yeah.
and the high effectiveness. Now, the knee of the curve is sometimes called the most cost effective because you're in a place where you're getting the best bang for the buck, so to speak.
Yeah, yeah, absolutely. Absolutely. Good. Okay. So,
So this is Ron Luman.
Yeah, hi, Ron.
Thank you, Howard. This is a good refresher for me. It's good to see that it's still kicking and has good applicability. My experience is that using a sort of surrogate metrics for effectiveness is often not satisfying to customers, government customers.
Mhm.
And they often like effectiveness to be, something intuitive as
Right.
opposed to
Mhm.
an artificial scale.
Right.
And so what can happen there, essentially, your effectiveness can be characterized by multiple factors. I mean, you
Right.
had an example in your probability detection, but you want to have that high, but you want false alarm rate to be low. In fact, in the COVID tests that we have these days, we've got exactly that problem with probability of false negatives and false positives.
Mhm.
It's the same exact problem. So what we can do in that case, and I've seen done and have done, is essentially you pick one parameter of many that you want to maximize as an effectiveness, but you set thresholds for the others. So you
Right.
can
Mhm.
say, I want to maximize probability detection, but I don't want my false alarm rate to go higher than a certain number. And then
Exactly.
you can have multiple metrics where you put mins and maxes on, and then you do an optimization. So that can work. It takes into account the complexity, but it does get complicated at the expense. You gain the intuitive nature of the metrics, and you preserve that, but you do gain some complexity in the analysis.
Sure. Well, the example I put in is sort of the simplest case, and I do completely agree. In fact, I remember when you did your dissertation, you chose a much more complete and complex evaluation
Yeah.
of alternatives.
Well, I had to do that in order for a dissertation. I couldn't make it this simple.
That's right. You bet. Exactly. You did a great job on that, by the way.
Thank you.
But do you remember the discussion of this point when you were in my class all those many years ago?
Yeah, that was great. Yeah, that was 25 years ago.
Exactly.
Yeah.
all right. Any more questions?
Does anybody want to comment on the DODEF approach and idea? I've heard from more than one person that the DODEF approach is not working for them.
Mm,
That they do an awful lot of work, but they don't feel confident that the work they do is useful and actually leads to an architecture. Anybody had that experience with DODEF that it's not working for them?
Well, this is Rob Cloutier, University of South Alabama. How are you doing, Howard? I have your book. I've enjoyed it. I don't know that I necessarily agree with all of it, but I do enjoy it, and I will use parts of it in my class. The challenge with DODEF is, though, if you're contractually required to use it, you got to do it. However else you come up with an architecture, if the contracts folks are saying, well, we've got to do this, and if the contract was written by someone that doesn't understand the tailoring of DODEF, you end up doing all the diagrams, whether it makes any sense or not. So, as well as I do, you've been in this business a little bit longer than me. You got to do what your contracts officers and contract organization says.
I completely agree, and I understand what you're saying. Yes.
I'm a fan of a logical architecture between the functional architecture and the physical architecture.
Mm-hmm.
The reason for that is it allows me to change out technology in the case where technology changes quickly. I'll use the classic FireSat example. You know, you can very quickly get to a satellite, but nowadays we could use drones. And if I had a logical architecture, I could swap out the satellite with a drone without changing my logical architecture at all.
Okay, good point. Mm-hmm.
Okay, and so that's the part I see missing out of what you're doing, different from what I've done in my professional life and now in my academic life in you know, running the program down in South Alabama. So, but architecting's near and dear to my heart, and I really enjoyed your presentation.
If at all possible, if you could send me an example of what you're talking about, I would be very grateful.
Yeah, I'd be interested in seeing if that logical, does that line up with the functional? Or are you
Well, now
separating those out?
it gets a little bit tricky because I'm a model-based system engineering
Right,
fan.
right.
And so we're not doing functionals, we're talking about objects, but the functions are embedded in the objects.
See, that's where I think maybe,
Because the objects got functions and you know,
Yeah.
behaviors and attributes.
and
but
that may be, yeah, that may be where there is a mapping between the two.
But even then, you know, I still end up with this logical architecture, which
Yeah,
abstract. I will, you know, send me an email or
we'll put his, Dr. Eisner, you want me to put your email
Oh,
address?
definitely, yes. Please, please circulate my email.
I
We're happy
would love to start a discourse with you. on this, Dr.
I'll
Eisner.
put it in the chat.
Great.
Okay,
Great,
now,
great. Thank you for that. That'd be very interesting to me. Yeah.
All right, we'll be pulling that up. Anybody else?
You mentioned one other thing that's sort of worth emphasizing, and that is the whole set of activities known as model-based systems engineering.
Correct, yeah.
And that's a very worthwhile set of activities. And although they're not one-to-one with what I presented, I certainly endorse that.
Sure. And you know, the interesting thing, it's a misnomer. As system engineers, we've been using models for decades from the get-go. Because
Sure.
you think that a model is a facsimile of reality, then your requirements document is a model.
Sure.
Okay? The charts that you've drawn, the diagrams you used in your book, they're models. So we've always been doing model-based system engineering. What SysML gives us,
I have to agree with that. I think it's from the very beginning, modeling has been
sure, but
a key component to system engineering. I think the problem is we've had models, different models all throughout, whereas model-based is trying to combine them all.
right, and that's the other challenge I have with this approach presented tonight is that it's on paper, it's paper-based, and there's, you know, if I change an artifact or change an answer on one slide or one page, because I mean, you say it's one page, but you've got like 4 pages describing what you did, so it's multiple pages.
Yeah.
Yeah, I caught you.
It could be a book, really. I mean,
yeah,
theoretically.
exactly. Oh, yeah, it is a book.
If you've ever seen, yeah.
Okay, so but the point is, if you change it in one place, you got to make sure you go through and change it through the decomposition. And
Sure.
if you don't do that, whereas in using a tool like SysML or even Core's Vitec or any of the other tools out there, you change it in one place, it changes it throughout. And there's a huge advantage there that you don't make the fat finger mistakes.
Yeah.
Mm-hmm.
So
Yeah.
I really am interested to, like I say, I wanted to listen to you talk about this because I've got the Kindle version of your book, and I really want to incorporate. I'm teaching system architecting next semester, and I really want to incorporate some of your thoughts into that. And so that's why I wanted to listen to you. It was very informative. I'd like to start there's your email. Okay, I will start up a email thread with you.
I'm happy to be on your list.
Great, thank you.
Thank you very much. Yeah.
I'm very intrigued by the fact, Dr. Eisner, that you're kind of going old school? I mean, it's like this is the way system engineering and you know what I mean, doing this architecture from the beginning, and you're trying to say, let's not forget the basics of
Well, again, I pointed to one of the basics that goes back to, I think, 1965,
oh yeah, give me that book
when
name.
the Department of Defense
Oh yes.
came out with the WESIAC report, and they basically said measures of effectiveness and cost effectiveness are pretty critical to how we evaluate and should be evaluating our systems. And many of the DoD documents, even much more recently, basically say, look, what we're in search of from you contractors out there is a cost-effective solution.
Yeah,
And those are key words.
they are. Yeah, great.
Those are still key words.
Yeah, no, absolutely.
So that's basically what led me through a circuitous route to ask the question, well, what would a cost effectiveness approach be to architecting a system?
Yeah, agreed.
Isn't it funny? We have to keep learning the same lesson.
Yeah, I
A
know.
mentor that said same crap, different decade.
Yeah, right. And they try to put a varnish on it. It's just not working.
And I'm very sympathetic to the comment that was made here about the contracting officer is looking for certain deliverables.
Yeah.
You better have the deliverables, even though they might not be your choice. Yeah, I've seen that in many times from many people.
I'm
I
wondering
had
if
a
you
hell of
could
a time
take that technical architecture and somehow make it the architecture you're talking about. But I think it's very prescribed. So maybe that's not something you can do.
I had a heck of a time back in the early 2000s trying to tailor DODAF on the Aegis project
Yeah.
using
Okay.
System
Maybe
L.
it's not working.
Yeah,
Yeah.
right.
Hey, Strickland, did you have a comment? I noticed you unmuted, so.
This is Stuart Strickland from Front Range in Colorado. One of the things that we've done is as we have had prescribed views in the contract, we've also looked at developing fit for purpose views, which allow us to present what we really want to present and what our customer really wants, but isn't really contained in any one or group of DODAF views that can be presented in a logical or effective manner. So the folks that I work with have tried to use and create our own fit for purpose views outside the contract, but we use those for our presentations. Over.
Yeah, that's really good.
Thank you for mentioning that, and please join our new group of people who are going to stay in touch via email.
Yeah, that'd be great.
I'll add another thing on top of all the rest of this. I'm Bob Koppelman. I'm a retired systems engineer from Northrop Grumman. DODAF can be very cumbersome, and it can get very detailed and involved, and you can get taken down a path where you're describing nits and details and have lost the view of the big system.
Right.
If you take and consider the constructs of Agile and try to combine Agile systems engineering with a DODAF approach, you can better define what do I want to accomplish up front and how long am I going to take, so that the DODAF doesn't run on and on and on.
Very good. Thank you for that comment. That's another important perspective.
Especially if you get lost in the details, like you said.
The only thing I'll say is you have to get to the contracting officer early so that they don't specifically call out diagrams.
Yeah.
Do the process tailoring. And that was the big argument I got into, is trying to tailor DODAF for that which we needed to do using an object-oriented approach instead of a functional decomposition. He said, but the contract says you got to produce this, and it was nuts. So great point, and I agree with you. If you can get involved early enough in the process to dictate what the contract deliverables will be.
Right, and DODAF, even today, I look at a language like C++, and C. A lot of us more seasoned engineers learned C.
Yep.
The first time, second time, maybe even the third time we tried to use C++, we wrote C++ that looked like C because we weren't experienced. We hadn't gone through the process. And I think a lot of times that's where we are in the DODAF, and there's one or two other versions of DODAF that are being used in other communities. The IC community has a version they use where learning to use it effectively is the first challenge to overcome. And our customer hasn't seen that. They don't have examples of that for them to say, this is what I want. So they go back to the book and they say, the book says, this is what I'm going to give.
Well, I hope that those of you who have commented on your workarounds, your DODAF workarounds and new approaches can share that with whoever basically signs up for an email on architecting.
Yeah.
You know, that's where we are with SysML also. People's trying to use SysML and they end up doing a functional decomposition instead of taking a step back and saying, as engineers, we deal with objects. What are the objects I need to deal with?
Yeah.
And then what do they have to do? And so we end up with a functional decomposed SysML approach. And while you can do that, you know, just because you can doesn't mean it's a good idea.
And actually, where I work, we're now trying to push the whole model based aspect of things.
Yeah,
Build
a lot of places
in a
are.
tool. Yeah.
I got a call from NASA Advanced Concepts a couple of weeks ago wanting me to do some work to help them migrate that way. And you think, holy smokes, NASA should be doing this. And
Oh,
yet,
yeah, really.
and anywhere you go, no matter what company, there's pockets of it, but it's not across the company yet. There's pockets. So we're just at the beginning upturn of the technology adoption curve. For those of you who know what I'm talking about, we're not in that, you know, accelerate. We're just making that turn from early adopters into acceptance.
So even in the model-based engineering, there's got to be something that defines the inputs to the model. What are the varieties that I can choose? Because if you write a model that has only a specific set of trades, you're not really looking at the broader concept. I mean, there may be newer technologies, there may be cheaper ways than what you have in your model. And as you say, a lot of people think you put it in the model, you push the button, and the answer comes out.
No.
No, you should have a model for each alternative, right? Or the model should be able to take each alternative.
That's correct. You include the alternatives in the model.
You need to
but I always start with a context diagram.
Yeah, correct. Yeah. Or
and even if that's done
OV1, guys, OV1. I had to throw that in there. Sorry.
Well, I hope that this has prompted us to share what we're doing with each other. I'm be very pleased to be sending and receiving information from those of you who have spoken up, especially about your workarounds on DODAF, the way that you've solved that problem with your contracting officers and your various stakeholders that are looking for various kinds of things. So I'd be happy to get some emails from a bunch of you whenever you can turn them loose.
All right, good.
The way I did it, Howard, is I left industry and became an academic.
There you
go.
go.
Not a bad approach.
Yeah, that's true.
I have never looked back.
It took me 54 years to do it.
Well, we're glad you did.
Okay, yeah, this is Kaz, Marquez Merrick. I guess I had a quick question about the, you had, talked about the three, typically you were showing three options.
Yeah.
Three architectures.
Yeah.
Now, I guess the only thing I can see is if you had drawn maybe a grid on another, saying again, another piece of paper, but on the second piece of paper, it's a chart showing your 3 points and then showing how you maybe fared this curve to show you where the actual downturn is, to see the knee, as opposed to, I mean, I'm looking at these numbers and I just couldn't get a good feel for it. And sometimes that visualization of those 3 points on a chart would have shown, you know, how flat it was, and all of a sudden it dropped off or went up or whichever way it was supposed to go to show you where, okay, yeah, you're paying a lot more over here on this one. But
Yeah, that chart is in the book.
Oh, okay.
There you
All
go.
right. Well, then, yeah, I guess.
So you have to win the book. Yeah.
Well,
Or buy it.
Well, I think I'm gonna have to buy it. I think I'm excluded from the
That's
contest.
actually a good question. Clinton, are we excluded? I think we are, aren't we?
We are. We ready to do the raffle here?
Yeah,
Actually, I did have
make sure.
one more
Hey,
question though.
One
This
more
is
question
Kaz.
from Kaz.
Oh, okay.
But this is more to the whole.
The chart you're talking about is page 15 in the book.
Oh, okay. All right. Thank you. No, this is more to the whole group. When you talk about needed curve, I've been kind of looking around off and on. I mean, people talk about now these all automated vehicles, you know, autonomous vehicles that they're having, you know, put on the roads. You know, I'm not talking about like a tank or UAV. I'm talking for self-driving cars that we're going to be possibly using in the next 5, 10, 15 years, right? And when we had the CSER, it was a guy from GM, and he was talking about autonomous vehicles and what, you know, GM's been doing. And I asked him a question. I said, where's the knee of the curve come in when the amount of adoption of how many vehicles are on the road before all of a sudden we start seeing a significant drop in, say, accidents and fatalities and things like that? And he didn't really have an answer. And I'm really kind of surprised, because I would think that, you know, that would be like sort of like your end goal to, hey, how do we want to prevent some of these things, rather than, hey, do we want to build this good system? It's like, no, you're talking about a system of systems where all of a sudden all these vehicles are on the road all maybe at the same time. What happens when you get 15, 20% of them on the road? All of a sudden we start seeing, you know, collisions go way down, and, you know, our insurance rates drop through the floor, whatever. But I just was curious, since this, you know, team of architects here and engineers, has anybody heard about that or seen it?
So it's your rate of adoption, and then when does that rate of adoption show significant?
Yeah, no, it shows significant, you know, downturn or whatever the right term is, and it's like, okay, how far along do we go before we think?
Do you have any architects that are
and when does it start to turn? And you know, and no one seemed to say anything. Now, granted, maybe the insurance companies are looking at this. And of course, maybe the insurance companies aren't, you know, talking to system engineers per se.
Yeah, right.
But man, maybe I'm in the wrong industry to look at. I'm not saying that. First, professionally, I'm not in the wrong industry. I'm just saying, you know, I want to kind of see what, you know, people think about that. And I just hadn't seen anything, so I was curious. Put it out to this group here to see if they've heard of it. If they haven't, and I guess you can stay on mute and say it that way. But again, I found it more of an academic interest, but it's still got very real solution to it. You know.
Sure. All right.
The domain in which you see the high effectiveness solution being selected more or less without question is something like the Joint Strike Fighter, where we basically said we're not going to go to war with a capability inferior to any of our possible enemies. And you can see what happened with the Joint Strike Fighter. That's the military domain is one I'm more familiar with, so I can't really comment on your question, which is a very good one, about cars on the road.
Yeah. All right, let's, if there are no more questions, let's go ahead and get Clinton in here. He's going to show us. I'll go ahead and, oh, good, you took over. Good job.
There you go.
All right.
All right, I'm going to spin this wheel here. Right before I do, let me give a short advertisement for next month's guest. So coming up next month, we're going to be hosting Dr. Jim Armstrong of the DoD, and he's going to be giving us a talk on he's going to be taking us on an unusual journey to applying systems engineering to industries outside the more traditional areas that those principles and practices normally get employed. So that should be interesting. All right, so I'm going to click the wheel here and see who wins.
And by the way, I really want to thank everybody for coming out. This is probably our biggest meeting, so it's huge.
Yeah.
So if you win, it's a good thing. James, beat me. All right.
So,
I don't know if you want to unmute and say, hey, thanks, but.
Hey everyone, what did I win?
His book. So he's going to show you, Clinton. You have to
I need to get back to my
Can you
Zoom
show
control.
your
Hold on a
video? You can show
we
your video. There we go.
Well, that's awesome.
Hold
Thank
on.
you.
There we go.
You
So
won,
you're gonna win this book.
You won Dr. Eisner's
Mr. Marcus.
book that he written on the tonight's topic, Systems Architecting Method Examples.
If you go to speaker
New
view,
approach
you
to
can see the
systems
whole
architecting.
thing. Yeah.
Yeah. So if you went, there's more detail, I think, online at our chapter site. So, James, I'll use the email that you registered with to make contact with you, and we'll get your mailing address.
Okay.
Right?
Yeah,
We'll
that would be
send that
fun.
out.
Yeah. And then I'll get that
James,
out.
you mind telling us where you're from, if you don't mind?
Yeah, I'm in the Colorado Front Range chapter.
There we go. So I
I'm
think we're
based in
gonna-
Fort Collins, and I'm a PhD student at
Right.
Colorado State.
Well, it's great to have you, but I'm just wondering if we need to charge for people to come to this, because we have to pay to get this thing to you. But we don't. Hey, could everybody do me a favor? I normally try to take a picture of everybody who's here. So you need to turn your video on, unless you're in a robe or something, you don't want to see yourself. But people, put your cell phone, I've got it on gallery. And once I have everybody, I'm going to say 1, 2, 3, smile, and we'll see if this works. Let's see, Control Alt. Yeah, I got to make sure I've got the right thing. Control right. All right, everybody else, you're looking good. Yeah. I'll wait just a little bit longer. Okay, got Hannah said. Anybody else? All right, everybody, looking good. Woodrow, you look good. Okay, 1, 2, 3, smile. All right, let's hope that worked. I'm going to try it out here, but you guys can unmute for a while there as I pull this up and see if it worked. All right. Yes. All right. Thank you. Good. Clinton, I guess you can wrap this up. Howard, we appreciate you being there. Oh, by the way, great talk, Howard.
Thank you. My pleasure.
Yeah.